Hi friends, in this video we are going to discuss about the concept of Kirchhoff's voltage law. Okay, so that is KVL. So this concept is very important in electrical networks and electrical circuits. There are so many subjects are based on the concept of Kirchhoff's voltage law. So that is the reason why we have to learn this concept, and this is very important concept. So here actually what is the definition of Kirchhoff's voltage law and how we are going to verify Kirchhoff's voltage law with the help of network. So in this video we are going to discuss about all these things. Okay, so first I am going to starting with the definition. So first I am going to start with the definition. So what is the definition of KVL means? The definition of KVL is in any loop. Okay, for example, in any loop, the applied voltage is equal to the sum of voltage drops in the loop is called as Kirchhoff's voltage law, that is KVL. Okay, now just observe this definition. In any loop, the applied voltage is equal to the sum of voltage drops in the loop is called as Kirchhoff's voltage law. Actually, we are talking about loop. Okay, in any loop means, for example, what I am doing in order to clear the definition. So what I am going to do, just I am going to consider one network or one circuit, and with the help of that circuit I am going to clear the definition. Okay, now see here what I am doing. If I am going to consider, for example, this is the resistance R1, and for example this one is the resistance R2, and for example this one is the resistance R3, and here the circuit is closed like this. For example, the circuit is closed like this, and here we are going to apply, for example, some voltage 10 volts. Okay, now here V is equal to 10 volts, and R1, for example, what I am doing, R1 is equal to 10 ohms I am taking, and R2 is equal to some 20 ohms. For example, R3 is equal to 30 ohms. Okay, now see this network. With the help of this network you will get everything. Okay, now see, the value of R1 is 10 ohms, R2 is 20 ohms, and R3 is equal to 30 ohms. Okay, now we are applying the voltage V is equal to 10 volts. Now when we are applying this 10 volts across this particular circuit, or in this circuit, definitely some amount of current, that is, for example, I am calling as I is the current which is flowing in this network. Okay, now what happened when the current is flowing through this particular resistances R1, R2, R3, then we are going to see some drops. So that particular drops we are calling as, for example, the drop across resistor R1 is, for example, I am considering as VR1, and here the voltage drop across the resistance R2 is, for example, VR2, and the voltage drop across the R3 resistance is, for example, VR3. Okay, now see here we are applying the total voltage V is equal to 10 volts, and we need to get the value of voltage drop across this R1, and we are going to get the value of VR2, that is voltage drop across R2, and again we are going to get the value of voltage drop across R3, that is VR3. It means we are applying the total voltage V is equal to 10 volts, and this applied voltage must be is equal to the sum of voltage drop across individual elements. Just observe this expression, very important. We are applying, it means this VT represents the total voltage we are applying, and here VR1 is the drop across R1, VR2 is the voltage drop across R2, VR3 is the voltage drop across R3. It means as per the definition, just observe here, in any loop means what? Any closed path we are calling as loop only. Okay, so here as per the definition, in any loop, the applied voltage, that is, the applied voltage is what? Applied voltage, that is VT, is equal to the sum of voltage drops across what? The sum of voltage drops in the loop. Sum of voltage drop means what? The voltage drop across R1, voltage drop across R2, voltage drop across R3. The sum of all these particular drops, VR1 plus VR2 plus VR3. Okay. The addition of all these VR1 plus VR2 plus VR3 represents the sum of voltage drops in the loop. So here the sum of voltage drops means the sum of voltage drop across elements. Okay, we can also add here the sum of voltage drop across individual elements in the loop. Okay, so here this expression we are getting with the help of this particular definition. Okay, so here I am telling you, in any loop, or simply we can say that in any loop, the applied voltage to the circuit, must be is equal to, must be equal to the sum of voltage drops across individual elements in the loop. Okay, so this is the definition of the Kirchhoff's voltage law. Okay, we can define the Kirchhoff's voltage law like this, or we can also define the Kirchhoff's voltage law like this. Okay, both are same only. In any loop, the applied voltage is equal to the sum of voltage drops in the loop is called as Kirchhoff's voltage law. We can also define in another way, that is, in loop or in any loop, the applied voltage equal to the applied voltage to the circuit must be equal to the sum of voltage drop across individual elements in the loop. Here elements represents what? R1, R2, R3. Okay, so here as per the definition we are going to writing the expression, that is this one. Okay, now we can also define the Kirchhoff's voltage law in another way, that is here the definition of Kirchhoff's voltage law in algebraic form. That is very important, all these concepts. Okay, now another way we can define the Kirchhoff's voltage law, that is the Kirchhoff's voltage law states that, or it states that the algebraic sum of voltages in a loop is equal to 0. Okay, so is called as Kirchhoff's voltage law. Now just see here Vt is equal to VR1 plus VR2 plus VR3. Vt is equal to VR1 plus VR2 plus VR3. I am writing this expression in the algebraic form. That is the meaning of algebraic means what? The meaning of algebraic means the sum of all voltages is equal to 0. It means actually the expression from the network is Vt is equal to the sum of voltage of VR1, VR2 and VR3, and this expression we are writing in algebraic form, that is Vt minus VR1 minus VR2 minus VR3 is equal to 0. Okay, so this equation represents the algebraic sum of voltages is equal to 0, and this expression represents the applied voltage must be is equal to the sum of voltage drop across individual elements in the loop. Okay, so this is the concept of Kirchhoff's voltage law. Okay, now for example I'm telling you, we have one for example we have one network like this, and we are applying some voltage here. Okay, for example this is R1, this is R2, and this one is R3, and we are applying some voltage is equal to 10 volts. For example, this is 1 ohm, this is 2 ohm, and this is 3 ohm. So how to verify whether the Kirchhoff voltage law in this particular network is verified or not? So by using the concept of calculation of total current, and after getting the total current in this particular network, we have to find the voltage drop across this one, and voltage drop across R2, and voltage across R3. It means the expression of voltage drop across VR1 is given by total current flowing in the circuit into R1, and the voltage drop across R2 is the total current flowing in the circuit into R2, and here the voltage drop across R3 is the total current flowing in the circuit into R3. Here, with the help of these three expressions, we can find the voltage drop across R1, R2, and R3. After getting all these values, we can verify Kirchhoff's voltage law. Okay, how much voltage we are applying, and how much voltage drop across getting across individual elements. After getting the voltage drop across individual elements by using all these equations, now after getting all the values, you can substitute in this expression, then whether applied voltage is equal to sum of voltage drop across individual elements or not. If for example from this expression you are applying 10 volts, and for example you are getting 3 plus 4 plus 3, for example the value of VR1 is 3 volts, the value of VR2 is 4 volts, and the value of VR3 is for example 3 volts, then 10 is equal to 10, then the Kirchhoff's voltage law is verified. Like this we need to verify in case of what? Kirchhoff's voltage law. Now by using these three expressions, we can find the value of voltage drop across R1, voltage drop across R2, voltage drop across R3. But in order to find this voltage drop, first we need to find the value of total current which is flowing in the network. So how to find the value of total current which is flowing in the network? By using the concept of what? Ohm's law. The total current is equal to total voltage divided by total resistance in the network. Okay, so here the total voltage is directly, we know that we are applying 10 volts, that's why 10 divided by the total resistance, means in this particular network R1, R2, R3 all are connected in series, that's why the total resistance means R1 plus R2 plus R3. Now we know that, so IT is equal to VT divided by RT, that is equal to 10 divided by 1 plus 2 plus 3. So here the total current is equal to 10 divided by 6. So here, so this particular current represents the total current which is flowing in this particular network. Now after getting this current, what you need to do now? With the help of this current, you can directly find the value of VR1. VR1 means what? Total current. Total current is how much? 10 divided by 6 into the value of what? R1. What is the value of R1? 1. You are getting 10 divided by 6 voltage drop across R1. Now here VR2. R2 is equal to what? Total current. Because in series connection, current is always same. That's why, so total current is always same for all the resistances. So 10 divided by 6 into the value of R2 is 2. Now here 2 3s are, it means what? So 10 divided by 3 volts. Now here VR3, here what? So total current 10 divided by 6 into the value of R3 is 3. Here 3 1s are, 3 2s are, it means what? 10 divided by 2. Here you are getting 5 volts. Now after getting all these values, what you need to do? How much we are applying? 10. What is the value of VR1? 10 divided by 6. And what is the value of VR2? 10 divided by 3. And what is the value of VR3? 5. Definitely this particular expression will gives the value of what? 10 is equal to 10. So like this, we need to verify Kirchhoff's voltage law. Okay, so this is a concept of Kirchhoff's voltage law. So in electrical networks or circuit, we need to use this procedure to calculate or to verify Kirchhoff's voltage law. Okay, so thank you so much for watching, and please do subscribe my channel for more updates. Thank you so much.